Okay. I actually titled my last video uh, reading from pages 143 to 155, but it's actually to 154. So we got to start at 155 today. So let's get some reading done. Let's review the last line from page 154 anyway. This is what we were at. Introducing final, that is the final keyword. So let's get going. A field can be declared as final. Doing so prevents its contents from being modified, making it essentially a constant. This means that you must initialize the final field when it is declared, making it essentially a constant. Okay, wait. Oh my God. You can do this in one of two ways. First, you can give it a value when it is declared. Second, okay, on to page 155. Okay. Second, you can assign it a value within a constructor. The first approach is probably the most common. Here's an example. So because I'm familiar with all of this, we're still in the basics. I'm going to just quickly skip through all of this, and you can post a video. I'll always highlight the images just for the sake of the video, so you, the reader, the audience can get a glimpse of it. Subsequent parts of the program can now use file open, etc., as if they were constants, without fear that a value has been changed. It is a common coding convention to choose all uppercase identifiers for final fields, as this example shows. In addition to fields, both method parameters and local variables can be declared final. Declaring a parameter final prevents it from being changed within the method. Declaring a local variable final prevents it from being assigned a value more than once. The group final can also be applied to methods, but its meaning is substantially different than when it is applied to variables. This additional usage of final is explained in the next chapter when inheritance is described. All right. Ooh. Arrays revisited. Okay. Arrays were introduced earlier in this book before classes had been discussed. Now that you know about classes, an important point can be made about arrays. They are implemented as objects. Mm, excuse me. Because of this, there is a special array attribute that you will want to take advantage of. Specifically, the size of an array, that is, the number of elements that an array can hold, is found in its length instance variable. All arrays have this variable, and it will always hold the size of the array. Here is a program that demonstrates this property. All right. Again, I already know this, so I'm just going to show it. Okay. I'm going to pause the video, and here's it, the result. As you can see, the size of each array is displayed. Keep in mind that the value of length has nothing to do with the number of elements that are actually in use. It only reflects the number of elements that the array is designed to hold. So what that means that whether you have a null value, zeros, ones, or objects in the array, that is for a regular array, the length will never change because it's designed to tell you how many it could hold, how many elements it could hold, not how many elements are actually deposited in the array. You can put the length to good use in many situations. For example, here's an improved version of the stack class. As you may recall, the earlier versions of this class always created a 10-element stack. The following version lets you create stacks of any size. The value of stack length is used to prevent the stack from overflowing. This is neat. Improved stack class that uses a length array member. Okay, stack private int stack private top of stack. Allocate and initialize stack. Stack int size, stack new int size, top of stack. All right, push an item onto the stack. There we go, same as before. Open item from the stack, same as before. Class stack 2. I thought that was stack 3 actually, but well. Stack my stack, new stack. Okay, push some numbers onto the stack of those numbers of the stack. Okay. Yeah, notice that the program creates two stacks, one 5 element deep and the other 8 elements deep. As you can see, the fact that arrays maintain their own length information makes it easier to create stacks of any size. Yeah, this is pretty cool. So let's see if we can find and compare it to the other stack. Oh, here. Okay, here's a stack class. So in this one, you put the name, the number of the array. Private stack, no int 10. So you can add more than that. And in the next one, let's go to 155. Here. No, 156, okay. In the next one, stack is not initialized. So you can initialize it with any size that you want. Yep. Here it is. That's a clever addition. All right, introducing nested and inner classes. Okay, it's possible to define a class within another class, and such classes are known as nested classes. The scope of a nested class is bounded by the scope of its enclosing class. Thus, if class B is defined within class A, then B does not exist independently of A. A nested class has access to the members, including private members, of the class in which it is nested. However, the enclosing class does not have access to the members of the nested class. Hmm. A nested class that is declared directly within its enclosing class scope is a member of its enclosing class. It is also possible to declare a nested class that is local to a block. There are two types of nested classes. Okay, let me put that up here. Static and non-static. A static nested class is one that has the static modifier applied. Because it is static, it must access the non-static members of its enclosing class through an object. Okay. That is, it cannot refer to non-static members of its enclosing class directly. The second type of nested class is the inner class. An inner class is a non-static nested class. It has access to all of the variables and methods of its outer class and may refer to them directly in the same way that other non-static members of the outer class do. The following program illustrates how to define and use an inner class. A class named outer has one instance variable named outer x, one instance method named test, and defines one inner class called inner. All right, here's you can pause the video to look at this. All right. Okay, so the inner class is says display later, but it's used inside the test method. Okay, so here this seems to contradict a little bit what he was just saying mm, about the axis. Okay, an instant class has access to the members, including private members of the class. However, the enclosing class does not have access to the members of the inner class. Well, oh no, 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 because it wasn't a member. It was a an object, so it's not a member. So it makes sense. Yeah, this is not an inner member. This is an object. Okay. All right. Okay. In the program, an inner class named inner is defined within the scope of class outer. Therefore, any code in class inner can directly access the variable outer x. An instance method named displayer is defined inside inner. This method displays outer x on the standard output stream. The main method of the inner class demo creates an instance of the outer and invokes its test method. The method creates an instance of the inner of the class inner, and the display method is called. It is important to realize that an instance of inner can be created only in the context of class outer. The Java compiler generates an error message otherwise. In general, an inner class instance is often created by code within its enclosing scope, as the example does. As explained, an inner class has access to all of the members of its enclosing class, but the reverse is not true. Members of the inner class are known only within the scope of the inner class and may not be used by the outer class. Yeah, it has to be accessed through an object of an instance of the inner class, like he showed in the first code. But this is the second one to show an error. I post the video if you like. Okay. Void showy is in the scope of the outer class. It's not in the scope of inner, but y is in the scope of inner and not outer. So that's why it will show an error. Okay. Here, y is declared as an instance variable of inner, thus it is not known outside of that class and it cannot be used by showy. Yeah, showy will need an object of class inner before it can show y. Although we have been focusing on inner classes declared as members within an outer class scope, it is possible to define inner classes within any block scope. For example, you can define a nested class within the block defined by a method or even within the body of a for loop, as this next program shows. See, there's a little bit I didn't know. Now that's interesting. Oof. Man, I'm excited about this. Can you build with this? What can you build with this? And my mind is running. All right. Finding our classes within a for loop. Class outer, int outer x 100, void test. Okay. For int, oh, there it is inside. Wow, that's pretty cool. Uh, there you go. Can I highlight this? Yeah, look at it right here. See, that is cool. That is the scope of the class, and then the rest is the scope of the int, of the for loop, and then that last bracket is the scope of void test method. That's pretty cool. All right, let's take that off. Okay, class table. Okay, outer test. Wow, that is so cool. That is very cool. The output, oh, the output situation of the program is shown here. Yep, that is so cool. Nested classes are not applicable to all situations. They are particularly helpful when handling events. We will return to the topic of nested classes in chapter 25. There, you will see how inner classes can be used to simplify the code needed to handle certain types of events. You will also learn about anonymous inner classes, which are inner classes that don't have a name. Oh, that's cool. One point of interest, nested classes were not allowed by the original 1.0 specification for Java. They were added by Java 1.1. Oof. All right, exploring the string class. Now, this is always a great topic. Strings are just lifesavers. All right, let's see. Although the string class will be examined in depth in part 2 of this book, a short exploration of it is warranted now because we will be using strings in some of the example programs shown toward the end of part 1. String is probably the most commonly used class in Java's class library. Absolutely. The obvious reason for this is that strings are a very important part of programming. The first thing to understand about strings is that every string you create is actually an object of type string. Even string constants are actually string objects. For example, in the statement, let's bring it up. Since in print line, this is a string 2. The string, this is a string 2, is a string object. Yeah. The second thing to understand about strings is that objects of type strings are immutable. Once a string's object is created, its contents cannot be altered. While this may seem like a serious restriction, it is not for two reasons. If you need to change a string, you can always create a new one that contains some modifications. Java defines peer classes as string called string buffer and string builder, which allows strings to be altered. So all of the normal string manipulations are still available in Java. String buffer and string builder are described in part 2 of this book. That's what I want to get, because this is all the stuff that I need from those classes. Strings can be constructed in a variety of ways. The easiest way is to use a statement like this. String, my string, this is a test. Once you have created a string object, you can use it anywhere that a string is allowed. For example, this statement displays my string and string. Java defines one operator for string objects. It is used to concatenate two strings. For example, this statement. String, my string, I like Java, results in my string containing I like Java. The following program demonstrates the preceding concepts. Demonstrating strings. Class string demo. Public static void main string. Okay. So I already know this stuff. You can just pause the video. Yeah. Here and now. Here and then. Yeah, but this program is shown here. Excuse me. Excuse me. Let me pause. Let me mute it for a second. Okay. A string class contains several methods that you can use. Here are a few. You can test two strings for equality by using equals. You can obtain the length of the string by calling the length method. You can obtain the character at a specified index within a string by calling char at. The general forms of these string methods are shown here. Okay. There we go. Boolean equals second string. Int length. Character at index. Here's a program that demonstrates these methods. Okay. Demonstration string methods, string demo. All right. Strobe b1, string object 1 dot length. Okay, and then string object 1 dot cart at 3. And now, okay, if string object 1 dot equals string object 2 and else. 1 equals to 3, and there we go. All right, and here's what that generates. Pretty cool. Oops. Oh my God. Uh, sorry. I need a way to slowly scroll this page. Okay. Of course, you can have arrays of strings, just like you can have arrays of any other type of object. For example, and here's a string array. Excuse me. Okay. And here's the output of this program. As you can, as you will see in the following section, string arrays play an important part in many Java programs. Oh man, command line arguments. Now this is something I have to learn. That's something that I'm gonna have to get back to after I read the book to actually use it. But I'm not using the command line so much, so I'm not gonna stop. Sometimes you want to pass information into a program when you run it. This is accomplished by passing command line arguments in main. A command line argument is the information that directly follows the program's name on the command line when it is executed. To access the command line arguments inside a Java program is quite easy. They are stored as strings in a string array passed to the args parameter main. The first command line argument is stored at args0, the second args1, and so on. Okay, that's really good to know. For example, the following program displays all of the command line arguments that it is called with. Display all command line arguments, class, command line. And here's the, let me highlight this here. This is the arguments that he was saying, arguments 1, arguments 2, and so on. I think that's what it is. That's what he's talking about. Yep. All right, so let's set that up. Okay, try executing this program as shown here. Java command line. This is a test 100 minus 1. When you do, you will see the following output. This is a test 100 minus 1. Wow. Wow. Hmm. You know, the courses that I took did not actually explain that arguments of the main method as uses actual parameters. So this is very enlightening, actually, very much so. They are actual parameters. That is so cool. Mm. String a dummy argument, and you can pass along information to it. You can manipulate it. That is so eye-opening. I wonder what else you could do with that. Hmm. That's pretty good. That adds a lot of flexibility to programs. Wow. Okay. Remember, command line arguments are passed as strings. You must convert numeric values to their internal forms manually, as explained in chapter 19. All right. It's pretty good. Now, but the terminal knows that this is a test 100. It's a string. At least we know that because it doesn't say otherwise there. Okay. Variable length arguments, default args. Oh, wow. I thought we'll check that later. Okay, modern versions of Java include a feature that simplifies the creation of methods. I need to take a variable number of arguments. This feature is called varargs, a variable number of arguments. This is short for variable length arguments. Oh, there you go. A method that takes a variable number of arguments is called a variable of, it's called a variable arity method. Mm, Variable arity method, or simply a varargs method. Hmm. I need to know that. Oh, a second. Let me see if we can look this up. Is it possible? Look up arity. Yeah, let's see. Let's see, right? We might learn something. Mm-hmm. Arity, making strong, making a strong affected or pretentious display of being artistic. Oh no, wait, that's artsy. It's art. Okay, arty. No, this is not. This is not exactly. No, no, it's not. It's not what we're looking for. Okay. I wonder what they call the variable RT method. I'd rather call it Varax because I don't know what the little word means. All right. Situations that require that a variable number of arguments be passed to a method are not unusual. For example, a method that opens an internet connection might take a username, password, file name, protocol, and so on. Hmm. But supply, supply defaults if some of this information is not provided. In this situation, it would be convenient to pass only the arguments to which the defaults did not apply. Hmm. Now that is interesting. Another example is the print f method that is part of Java's I/O library. As you will see in chapter 22, it takes a variable number of arguments, which it formats and then outputs. Yeah, the flags. That's a pretty interesting print method. Um, I can't wait till we get to networking. Wow. In the early days of Java, variable length arguments could be handled two ways, n- neither of which was particularly pleasing. First, if the maximum number of arguments was small and known, then you could create overload unloading versions of the method, one for each way the method could be called. Although this works and is suitable for some cases, it applies to only a narrow class of situations. In cases where the maximum number of potential arguments was larger, or unknowable, a second approach was used in which the arguments were put into an array and then the array was passed to the method. Oof. This approach, which you may still find in older legacy code, is illustrated by the following program. Oh, that's smart. Let's see. Use an array to pass. Oh, give me a second. I'm sorry. I need to have something here. Okay. Here we go. All right. See. Okay. All right. So, all right. Use an array to pass a variable number of arguments to a method. This is the old style approach to variable length arguments. Class pass array. Static void variable test int v. That's an array. System print number of args dot v dot length plus contents. Okay. For int x, also for every item in the v array. Okay. System print out x. Print out. That's a pretty interesting way of doing it. Oh my god, that's really interesting. Wow. Well, because it will create an array, the length of the number of arguments that you will have put in there. Well, how does that work? Because you don't have commas, you don't have the ellipsis either. Let's see. Let's see this in play. Notice how an array must be created to hold the arguments. Oh, of course. Yeah. So you must pass an array. You don't have a choice. Yeah. Yeah, but that's a very limited way of doing this. You uploaded the program is. Yep. In this program, the method that tests is pass its arguments through the array V. This old style approach to variable length arguments does not enable that test to take an arbitrary number of arguments. Yep. However, it requires that those arguments be manually packed into an array prior to calling that test. Not only it is tedious to construct an array each time that test is called, it is potentially error prone. The virus feature offers a simpler, better option. A variable length argument specified by three dots. Oh yeah, so that's the ellipsis. That's what I was saying. For example, here's how that test is written using vararg. Excuse me. Static void that test int. Yeah, there you go. This syntax tells the compiler that that test can be called with 0 or more arguments. As a result, v is implicitly declared as an array of type int. Thus, inside. Oh, I didn't know that it was implicitly declared as an array. See, I didn't know that. That's the underworkings of the compiler. Thus, inside that test, v is accessed using the normal array syntax. Here's the preceding program rewritten using a vararg. Alright, that was a variable length arguments. Vararg now uses a vat test now uses a vararg. Static void vat test int ellipsis v. Okay. V. Alright. Okay. Very cool. Very cool. You can use this in combination with strings and stuff, I suppose. Not necessarily. Um, nice how vat test can be called with a variable number of arguments. Yep. Yep. The output from the program is the same as the original version. Let's bring this up. There are two important things to notice about this program. First, as explained, inside the vat test, v is operated as an array. This is because v is an array. Wow. The syntax, the ellipsis syntax simply tells the compiler that a variable number of arguments will be used, and that these arguments will be stored in the array referred to by v. Second, in main, vat test is called with different numbers of arguments, including no arguments at all. The arguments are automatically put in an array and passed to v. In the case of no arguments, the length of the array is 0. A method can have normal parameters along with the variable length parameter. However, the variable length parameter must be the last parameter declared by the method. For example, this method declaration is perfectly acceptable. Int do it. It's a lot I like him. Int A, int B, double C, int variable lengths. Okay. And how will you manage these though? Because the first ones are not arrays and the variable lengths are arrays. So let's see how he explains that. In this case, the first three arguments used to call it do it. Oh, excuse me. Sorry. In this case, the first three arguments used in a call to do it are matched to the first three parameters. Then any remaining arguments are assumed to belong to vals. Remember that vararg's parameters must be last. For example, the following declaration is incorrect. We do it int b, double c, int vals, boolean stack flag. Error. Yeah. Okay. Here is Here, there's an attempt to declare a regular parameter after the varch's parameter, which here, which is illegal. There is, and there's one more restriction to be aware of. There must be only one varch's parameter. Uh, yeah, okay, I see. Yeah, okay. The attempt to declare the second varch's parameter is illegal. Here is a reworked version of the test method that takes a regular argument and a variable length argument. Sorry, I'm recording this at 1:37 a.m. Uses varargs with standard arguments, class varargs too. Okay. Here, message is a normal parameter and v is a varargs parameter. Static void var test, string message int varargs. System out. Okay. Length, contents, v. Okay. And then here's how we use it. You can stop the screen anytime. One vararg. Yeah, three varargs. Yeah. That's the cat. Summer window. Oof. All right. Overloading vararg methods. You can overload. Oh, that's good to know. No, didn't think of it. Oh, you can overload a method that takes a variable length argument. For example, the following program overloads var test 3 times. See. Okay, there's three. Static void var test int variables. Yeah. Okay. It's var test one. Var test boolean. Okay. That is so cool. Strings. Yeah. Mhm. Yeah. The purpose for this program. You can pause the screen here if you like. Okay. This program illustrates both ways that various methods can be overloaded. First, the types of these various parameters can differ. This is the case of vattest int and vattest boolean. Remember, the ellipsis causes this parameter to be treated as an array of the specified type. Therefore, just as you can overload methods by using different types of array parameters, you can overload variable methods by using different types of variables. In this case, Java uses a type difference to determine which overload method to call. The second way to overload a variable method is to add one or more normal parameters. This is what was done with string int. In this case, Java uses both the number of arguments and the type of arguments to determine which method to call. A note. Note, a var method can also be overloaded by non-varchar methods. For example, vattest int x is a valid overload of vattest in the foregoing program. Okay, this version is invoked only when one int argument is present. When two or more int arguments are passed, the var version int var is used. Oh, I see. Oh, wow. That makes sense though. Seems common sense. Variance and ambiguity. Somewhat unexpected errors can result when overloading a method that takes a A variable length argument. These errors involve ambiguity because it is possible to create an ambiguous call to an overloaded Varix method. For example, consider the following program. All right, let's see. Patterns overloading ain't ambiguity. This program contains an error and will not compile. Okay, so here it is. Vec test 1 int vars. Okay. Vec test boolean. Boolean, okay. All right. But there's only two. Vec test. Oh, this one doesn't have anything. Well, I will assume that since you don't have a constructor for it, that the system would not let you call it like that in the first place, I imagine. In this program, the overloading of that test is perfectly correct. However, this program will not compile before because of the following call. That test. Yeah. Because the parameter can be empty. Oh, now I get it. This call could be translated into a call to val int or val test boolean. Both are equally valid, thus the call is inherently ambiguous. Yeah, here's another example of ambiguity. The following overloaded versions of val test are inherently ambiguous, even though one takes a normal parameter. Let's see. Although the parameter list of val test differ, there's no way to compare the result of the following call. Oh yeah, because you have two parameters of the same type. Yeah, because the second one, the second one can take one argument plus zero arguments, this one, which equals one. And the first one can take also zero or one. So I can see how that's an issue. Yeah. Yeah. Does this translate into a call to test int, which one varix argument, or into a call to test int with no varix argument? Yeah. There is no way for the compiler to answer this question. Thus, the situation is ambiguous. Because of ambiguity, errors like those just shown, sometimes you will need to forgo overloading and simply use two different method names. Also, in some cases, ambiguity errors expose a conceptual flaw in your code, which you can remedy by more carefully crafting a solution. Yeah, the solution in this case was to just craft the second one. Well, I mean the first one. Yeah, that's it. Local variable inference with reference types. As you saw in Chapter 3, beginning with JDK 10, Java supports local variable type inference. Recall that when using local variable type inference, the type of the variable is specified as var, and the variable must be initialized. Earlier examples have shown type inference with primitive types, but it can also be used with reference types. In fact, type inference with reference types constitutes a primary use. Here is a simple example that declares a string variable called myString. Variable myString uses a string. Because a quoted string is used as an initializer, the type string is inferred. As explained in Chapter 3, one of the benefits of local variable type inference is its ability to streamline code, and it is with reference types where such streamlining is most apparent. Right. The reason for this The reason for this is that many class types in Java have rather long names. For example, in chapter 13, you learn about the file input stream class. which is used to open a file for input operations. In the past, you could declare and initialize file input stream using a traditional declaration like the one shown here. File input stream fin new file input new file input stream test.test. With the use of var, it can now be written like this: var fin new file input stream. Yeah, so that's a little convenience. Yeah, here fin is inferred to be a type of file input stream because that is a type of its initializer. There is no need to explicitly repeat the type name. As a result, this declaration of fin is substantially shorter than writing it the traditional way. Thus, the use of var streamlines the declaration. This benefit becomes more apparent in more complex declarations, such as those involving generics. Yeah. In general, the streamlining attribute of local variables type inference helps lessen the tedium of entering long type names into your program. Okay, I'm gonna pause for a second because I gotta drink some water, and I'll be right back. Okay, let's go back to our rating. Okay, how close? See. Okay, let's put this up. Of course, the streamlining aspect of local variable type inference must be used carefully to avoid reducing the readability of your program, thus obscuring its meaning. For example, consider a declaration such as the one shown here. Who knows? For X, O that get next. We don't even know what type O is. Or what type get next returns. So I can understand how this is obscure. In this case, it may not be immediately clear to someone running your code what the type of X is. In essence, local variable type inference is a feature that you should use wisely. As you will expect, you can also use local variable type inference with user-defined classes, which are generics. As the following illustrates, well, actually, any class. As the following program illustrates, it creates a class called myClass and then uses local variable type inference to declare and initialize an object of that class. Sorry about that. My nose is still a little stuffy. I have a cold, so I have to pause the program sometimes. Alright, hold on a second. Here we go. Okay. Oops. Alright. Local variable type inference with the user defined class type. Class my class, private int. My class is a method. No, that's a constructor. I was okay. Int get I. Return I. Void set a getter and a setter. Okay, set I int k. Int k. All right. If k is bigger than 0, k is bigger than 0 is bigger or equal to 0, I equals k is equals I. Basically, won't let you put a negative number. Excuse me. Class ref variable demo main my class 10, or let's use a var here. Yeah, so it's inferring um, the type of a variable that MC is. The MC get I. Okay. Value of I in MC is now. Okay. Yep. Interesting. The output of the following program show here. Yeah, let's bring that up a little bit. Okay, in the program, pay special attention to this line. var MC new my class 10. Notice the use of var here. All right. Here, the MC will be inferred as my class because that is the type of the initializer, which is a new my class object. As explained earlier in this book, for the benefit of reader working in Java environments that do not support local variable type inference, it would not be used by most examples in the remainder of this edition of this book. This way, the majority of examples will compile and run for the largest number of readers. Good job. Oh, we made it to chapter 8, Inheritance. All right, so this is pretty good. We actually should pause here so that we can start a new video right on that first page of the chapter. So that's what we're gonna do. Okay, we're gonna record the next video there. So excuse me. Thank you for accompanying me and stay tuned.